You must have seen this at least once if you have used any Linux-based distribution. Init, short for initialization, is the first process started during booting of the computer system. Init is a daemon process that continues running until the system is shut down. The most famous init system out there is systemd. If you have been in the Linux community forums related to systemd, you would look at systemd and be like, there's nothing worse than this. Systemd is a devil. These people do have some good points. Uh, but why I love systemd is that it standardized the init system. The very first process to wake up and get everyone else going when a Linux computer boots is called init. Although we'll soon discover that the names can be misleading. You can see, for example, yourself that the first process that runs is init. By running the ps command, we can exactly see what's happening here. I will explain the details in a minute. The rightmost column of the output /sbin/init on the first line represents the location and name of the file behind the process itself. In this case, it's a file called init that lives in the /sbin directory. The leftmost column on the first line contains the word root and tells us that the owner of the process is the root user. The only other piece of information that interests us right now is the number 1, which is the process ID or PID of the init system. The only way you're going to get PID1 is by getting there before anyone else. By the way, the second line displayed by the ps command is the process assigned to the grep command itself. Note how its owner is Sahil Arora, my username, and its PID is much higher than 1. Before moving on, it's worth spending more time with the ps. As you have seen, PS displays information about active processes. It's often important to have access to process related information so we can properly plan and troubleshoot system behavior. You can expect to use PS early and often. If you were to type just PS and run it, you'd probably get two results. The first, a process called bash that represents to bash command interpreter being used by your current shell session, and the most recent command, which of course was PS. But by looking at the PID assigned to bash 7494 in this example, you just know that there are lots and lots of other processes already at hard work somewhere on your system. They will have been spawned by parent shells going all the way back to the init process itself. If you want to visualize parent and child shell processes, you can use the ps3 command, adding the -p argument to the display PID number of each process. Note how the very first process assigned the PID1 is systemd. On older versions of Linux, this would have been called the init instead. Go ahead and try all these commands on your own machine. Even on a quiet system, you'll probably see dozens of processes. A busy desktop, PC or server can easily have thousands. Technically, the systemd's primary job is to control the way individual processes are born, live their lives and then die. The systemctl command is the tool of choice for those tasks, but somewhat controversial. The systemd developers expanded the functionality far beyond the traditional role of the process management to take control over various system services, including under the new systemd umbrella are tools like logging manager, which is known as journald, network manager, networkd, and device manager, you can guess which is udevd. Let's talk about the history of systemd. Leonard Pottering, who worked at Red Hat, initially developed systemd in the early 2010s. They sought to surpass the efficiency of the init daemon in several ways. They wanted to improve the software framework for expressing dependencies to allow more processing to be done concurrently or in parallel during system booting, and also to reduce the computational overhead of the shell. In May 2011, Fedora became the first major Linux distribution to enable systemd by default. So let's talk about the design of systemd. Pottering described systemd development as never finished, never complete, but tracking progress of technology. In May 2014, Pottering further described systemd as unifying pointless differences between distributions by providing the following three general functions. Systemd includes features like on-demand starting of daemons, snapshot support, process tracking, and inhibitor locks. It's not just the name of the init daemon, but also refers to the entire software bundle around it, in which, in addition to the systemd init daemon, includes the daemon journald, login d, network d, and many other low-level components. Let's talk about the core of systemd. Following its integrated approach, Systemd also provides replacement for various daemons and utilities, including the startup shell script, pmutils, inetd, acpid, syslogs, watchdog, cron, and atd. Systemd's core component includes the following: Systemd, which is the system and service manager for Linux operating system. Systemctl is a command to introspect and control the state of systemd management and service manager, not to be confused with systemctl, which is different. Systemd analyze may be used to determine system boot up performance statistics and retrieve other state and tracing information for the system and service manager. There are ancillary components which provide the Linux init system. The systemd suite can provide additional functionality, include the following components: journald. The systemd journal is a daemon responsible for event logging with append only binary files serving as its log files. The system administrator may choose whether to log system events with systemd journald, sys and log ng, and rislog. The potential of corruption of the binary format has led to much heated debate. Login. System login is the daemon that manages user logins and seats in various ways. It is an integrated manager that offers multi-seat improvements and replaces ConsoleKit, which is no longer maintained. For the X11 display manager, the switch to login requires a minimal amount of porting. It was integrated in the systemd version 30. udevd. Udev is a device manager for Linux kernel, which handles the /dev directory and all user space actions when adding and removing devices, including firmware loading. In April 2012, the source tree for Udev was merged into systemd source tree. On 29th May 2014, support for firmware loading through Udev was dropped from systemd, as it was decided that the kernel should be responsible for loading firmware. But systemd started with a controversy at its launch. The design of systemd has ignited the controversy within the free software community. Critics regard systemd as overly complex and suffering from continued feature creep, arguing that it violates the Unix philosophy. There is also concern that it forms a system of interlock dependency, thereby giving distribution maintainers little choice, but to adopt systemd as more user space software comes to depend on its components. Specifically, that it tries to re-implement many existing services instead of improving or integrating existing ones. For example, user switching, network management, logging, etc. People who don't like the idea of everything relying on systemd interfaces to work at all. For example, GNOME started to rely on login and other services even though it technically didn't need to. Portering also created many interesting projects which were both a bit complex and pushed before they were ready, like Pulse Audio and PackageKit. Since they were forced on people via popular distros, Pulse Audio became the thing that's always broken for a year or so. And since Leonard also was the author, he became a person who breaks the system. But we do have some good news on the Pulse Audio side. Fedora 35 this April would be replacing Pulse Audio with Pipewire, which is a complete re-implementation of the whole sound server from scratch. It doesn't care about the compatibility with other OSs like BSD because it uses Linux only feature that meets its needs. The only real problem with this is systemd is solving enough problem for other people that people are starting to use it as dependency. Example, login is considered useful by many window managers. Rather than seeing this as, hey, they are solving useful issues, normally it is treated like some sort of evil conspiracy. It takes a devious mind to solve other people's problem, so they use your code after all. The main benefit of systemd is that it gives us faster boot times, but the shutdowns are slower. I would really love to have plain text log instead of binary logs, as it would help me find the problem in my system faster. But right now we are heavily dependent on it and we have no other choice. The Linux community is working really hard to develop a better and more modular init system which will one day replace systemd. If you want to learn more about systemd, I would really recommend you look into systemd homed, which provides a service for human user account that are not dependent on current system configuration. This systemd homed achieves the portability by moving all user-related information into a storage medium, optionally encrypted, and creating an .identity file that contains signed information about the user. passwords, and which group they belong to, UID or GID, and other information that would be typically scattered over multiple files in root. So please take some time to look at the init system and particularly learn more about systemd. It's an awesome piece of software that you can learn more about, and you can look over at its GitHub repo. It's heavily under development, and you can learn more about how do they do things right and how do they do things wrong.